Most students think definite integrals are just formulas, but they actually represent something powerful, the area under a curve. And the crazy part? You can find that area without graphing, just using one formula. A definite integral represents the net area between a function and the x-axis from a to b. And we indicate that by the definite integral from a to b of the function f of x dx. If the area is above the x-axis, that will be a positive area, whereas if it's below the x-axis, it will be a negative area. It is the side net area, not just total area. So here's the rule. The integral from a to b of f of x dx will be equal to capital F of b minus capital F of a, where the capital F of x is the antiderivative of f of x. So first you need to find the antiderivative. So you'll compute capital F of x from f of x. Then you'll evaluate the upper limit of integration. So evaluate f of b. Then evaluate the bottom number, which is the lower limit, f of a. And then you subtract. So you'll do f of b minus f of a. For example, if we want to find the area under y equals x squared from 0 to 2, that is the equivalent of the definite integral from 0 to 2 x squared dx. So first we need to find the antiderivative. Antiderivative of x squared with respect to x will be x cubed over 3 using the power rule. And then we can evaluate. So we'll put our antiderivative in brackets like this with our limits of integration on the right side. So first we evaluate when x equals 2. That will be 2 cubed over 3, which is 8 over 3, minus when x equals 0, that will be 0 cubed over 3, which is 0. So 8 thirds minus 0 is simply 8 thirds, and that is our answer. This is the exact area of the region bounded by x squared, the x-axis, and the vertical lines x equals 0 and x equals 2. In this second example, we want to find the area under one arch of sine, that is the integral from 0 to pi sine x dx. So first we find the antiderivative of sine x, which is negative cosine x. Then we can evaluate from 0 to pi. So first we'll evaluate when x equals pi, so negative cosine pi, minus evaluate when x equals 0, so negative cosine 0. Negative cosine pi is equal to 1 minus negative cosine 0 is negative 1. So 1 minus a negative 1 is 2. And as we can see here, the area from 0 to pi of the function sine x bounded by the x-axis, this area is 2. In this next example, we want to find the integral from 0 to 1 of 2x cosine x squared dx. This is one example where we'll need to use u-substitution. If we let u be x squared, du will be the derivative of u, which will be 2x dx. Now before we can substitute, we also need to change the limits of integration, because these limits from 0 to 1 correspond to x values. Since we're substituting from x to u, we need to substitute our limits from x to u as well. So when x equals 0, since u is x squared, 0 squared will be 0, so u will be 0. When x equals 1, 1 squared is 1, therefore u will be equal to 1 as well. Now we can substitute. If we rewrite our integral, that will be integral from 0 to 1 cosine u, because remember x squared is u and 2x dx is du. The antiderivative of cosine is simply sine, so we can evaluate from 0 to 1. So that will be sine 1 minus 0, which is sine 1. Since it's not an exact number, we'll just leave it as such. Here's your challenge for today. Evaluate integral from 1 to 3 of 2x plus 1 dx. Think about it. What does this represent? It represents area. Please try to solve it and leave your answer in the comments below. Here's a fast track summary. Definite integral equals area. The integral from a to b of f of x dx gives the signed net area under the curve between a and b. You'll need to find the antiderivative and always compute f of b minus f of a. When the integrand is composite, substitute and change the limits to match the new variable. Master this and calculus becomes much easier. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.